Okay, so did you figure out which way point B is going to move? All right. I'm thinking that a few of you probably guessed like up and to the right. Some of you probably guessed to the right because that's the way the velocity is going. Some of you may have guessed down, but remember this is a transverse wave. So really the only two options, because transverse means they vibrate perpendicular to the direction of motion. So if the motion is going to the right, really the only two options are up or down. So which way is it? Is B going to move up in the next instant in time or down? I'm pausing so that those of you that pick something other than up and down can rethink for a second. Okay, so what you need to imagine is that B throughout the whole thing is moving like this, and you're over here and it's like you're pulling the string. You're pulling the wave. The whole wave is moving this way. The whole wave is moving to the right. Then in the next instant in time, B is going to move down, because in the next instant in time, this trough that's behind it is going to be here. Right? Think about if you're in the water and a wave is coming towards you, what does it do? In the next instant in time, if you're over here, this crest is going to pick you up. You always do. You, the particle that's moving in the wave, always does what's behind you, what the wave's doing behind you. So if this is you in the water, this crest is going to come in and pick you up. And then you're going to be dropped into the trough when the trough gets to you. So in the next instant in time, B is actually going to move down. Whereas C, here's C over here, C would move up because the crest is coming to it. And what would A do? A's over here, and assuming that there's a trough behind it, A would also move down. Okay, so I know it'll take you a couple of minutes to figure that one out, but go back and think about it for a minute or two. All right, before I go too much further, I should probably do the homework that I asked you to do for today. And that was on page 341. Whoops, sorry, it's where I put my hand in connection to the light. Page 341, and it was just 1 to 4, and it was on periods. So the first question, and frequency. First question is a metronome, and a metronome is just something that keeps time. For those of you who are into music, you've probably heard of a metronome before. So it beats 54 times in 55 seconds. So the number of times it beats is capital N, 54 times, and the delta T is 55 seconds. And so the question wants you to find the frequency and the period. So remember, frequency is N over T. So it's 54 divided by 55 seconds. Whereas the period is delta T over N. So it is 55 seconds divided by 54. Now in math you might leave it that way, but if I asked you what's the frequency and you said 54 over 55 hertz, really doesn't do too much for us. So we would write this as 0.918, and the 1/8 are repeating hertz. And then the frequency, 55 divided by 54, or just the reciprocal, 1.0185, and the 185 are repeating, and that's seconds. So that's it. That's all you had to do for number 1. Number 2 says, most butterflies beat their wings between 450 and 650 times per minute. So N1 is 450 times, N2 is 650 times, and the amount of time that passes is 1 minute or 60 seconds. And so the question says, calculate in hertz the range of frequencies. So it wants you to find F1, which will be N1 over T. So 450 over 60 seconds. And F2, which will be N2 over delta T, which will be 650 times over 60 seconds. So cancel out the zeros, 45 over 6, that's going to be 7.5. and it'll be hertz, 1 over seconds. Cancel out the zeros, 65 over 60, 9.2 thirds, 9.6 repeating, I think, but I'm going to check it just to make sure. Oh, how did I get 10? How did I get that wrong? That's really bad. 10.83 repeating. Of course 6 goes into 65 more than 9. 10.83 repeating hertz. Okay, so that's all it wanted, the range. Number 3. A watch spring oscillates with a frequency of 3.58 hertz. So this time it's telling you the F is 3.58 hertz. And it wants to know how long does it take to make 100 vibrations. How long? It's looking for the time. Does it take to make 100 vibrations? That's your N. So knowing that F is equal to N over delta T, you need to rearrange for N. What are you going to do to get delta T off the bottom? Hopefully you all just answered multiply by T. And so N is equal to 3.58 hertz times... I wasn't solving for N. Don't do that. I'm solving for T. So F delta T is equal to N. Delta T is equal to N over F. There we go. So 100 divided by 3.58 hertz. Okay, so type that in your calculator. 100 divided by 3.58, and you get 27.933. Now, what are the units? Nothing up here, so 1 over 1 over seconds. 1 over 1 over seconds. Dividing by a fraction is like flipping and multiplying, so it should be 27.933 seconds when you flip and multiply. Okay, and that's it for number 3. Number 4. A child swings back and forth on a swing 12 times in 30 seconds. 12 times, that's an N. In 30 seconds, that's delta T. 12 times in 30 seconds, determine the frequency and the period. So frequency, N over delta T. 12 over 30. Goes in 0.4, I believe, hertz. And period is delta T over N. So it'll be 30 seconds over 12. 3 goes into each of those. 10 over 4, 2.5 seconds. Okay, so that was it. That was all your homework. Pretty pathetically simple, hey? All right, let's go back to your sheet for just a couple of seconds, and then we'll be done, and I'll give you some problems to work on. So we just finished the bottom down here, okay? So on the next side, in phase, you've probably heard of the idea of in phase. If you have a wave, 2 points on that wave are in phase with each other. If they are doing exactly the same thing at the same time. So point A is about to move down. Point C is also about to move down. They're both at exactly the same spot on the wave. They're at the top of the crest. There's one full wavelength between them. They're exactly the same distance from the rest position. So in order to be in phase, there's a few criteria that are necessary. Okay? And that few criteria is they have to be the same, so displaced from their rest position by the same amount, in the same direction, and moving in the same direction. Okay, so that's what it means to be in phase. All right, we're almost about to run out of video time again. For the rest of the class, I would like you to work on the very back of the last sheet in the packet that I gave you. It's called a Waves Worksheet, and it's with the formulas that I've shown you today, and there are 10 questions. And you have tons of time. Oh, actually, I lied. There's